Hey everybody, Lars here. Sick of me yet? Sick of Python yet? You should be. You have a video every night for 3, 4 days. I'd be sick of it. Oh, I'd say go pound salt. This is crazy. This is abusive. This is abusive programming. But I want you to see what I'm going to do. I'm going to be quick. What time is it? 10:52. I'm going to try to do this in 10 minutes, which is a lot. It's going to go longer than that. Hopefully, maybe 15. I don't know. I'm going to get started. I'm going to stop talking. If you remember back in Unit 2, when you first got some neat things in your toolbox, like iterating with loops, we took a look at Euler 6. We went to Project Euler and we looked at the sixth problem. And I coded it up real quick. Let's see. There's an interactive window and there's some code. So if you remember, we jumped into a loop and we found the sum of the squares, and then we jumped into another loop and we found the square of the sums. You remember we just did an accumulator, and then when we jumped out of the loop, we squared everything because that's what we wanted to do. And then we found the difference of those two things. Now, we had a worked example, and we did it for 10, and it came out to 2640. So then we said to ourselves, okay, in order to solve our problem with Project Euler, we want to do it with 100. And originally we had hard-coded things, but then we added limits, so we only had to change it in one place. And we added the 1 because we know that the end of our intervals in Python are exclusive. Okay, there are the first thing you don't want. So you add the 1 there to the variable, and then everything is good. And that is how we solve things with loops. But now you have more things in your toolbox, because now you know about functions. Okay? So you know about compartmentalizing your logic and compartmentalizing your code and thinking in your mind, okay, most problems are complex. You're not going to do just one thing. So in this particular problem, you really have 3 things. You want to find sum of the square, then you want to find the square of the sum, and then you want to find the difference. So now, knowing what you know now about functions, and if you've gotten to the end with modularity and libraries and things like that, you kind of may look at Euler a little differently. Okay? So, if I'm looking at Euler from scratch, when I'm thinking about doing it with functions, what would I do? Okay? What I would do, and I'm going to do it while we talk, I would basically define a function. I would call it sum of square, and I would take an integer n. Then I would zero out my variable, which I'm just going to make s in this case. And here I'm going to say for I in range, only this time, instead of limit, I'm going to say n because I'm going to use what I passed to the function. And then I'm going to say s is equal to s plus the square. And then I'm going to return s. Okay? In a similar fashion, def square of sum, and boom, boom, no. I'm going to come over here, and I'm going to actually also call this interior variable s. I can do that because of scope, yes? Because of scope, once that function above is run and then finishes, it goes away. So now I can reuse those variables if I'd like to inside of another function. And I can say s. Hey, how do we get down there? S squared. And just like above, I'm going to say return s. Okay? And then, and this makes me feel like an old C programmer, I'm going to create a comment. I'm going to say main. Because what we used to do back in the dinosaur days is we would write all our functions above at the top of the program, and then you would have a main section which kind of ran everything. Okay, and that's kind of what we're going to do here, because in our one print line, we're going to say the diff is, and we're going to call square of sum, but we're going to call it with 10, and then we're going to call sum of square, and we're going to call it with 10. And if we've done our functions properly, when I call square of sum, it's going to go square of sum 10. It's going to zero out the variable s, and then, good thing I ran through it. Good thing I did this, or that would have been an error. And then in range 1, 2, n plus 1, 11, it's going to do our calculation for us and return that s. That s is going to be right here where the function was called. And that s is going to be, well, whatever it is, 3025 or whatever it turned out to be. And then this one here is going to call the sum of the squares. And then you're going to add everything up and return that. And you're going to get that number. Let's see if things worked, because maybe things are buggy. An unexpected indent block. I can't believe it. Should have seen that one right away. All right, and the difference is 2640. So I'm in pretty good shape. Now, all I have to do is change it in the two spots. 25164150, if you recall, that is the answer. Okay? Now, if we want to we can just do this, and then we are back to our old functionality. So that we are only changing the variable in one place. Okay? So now, that is how we would attack Euler 6 now that we know about functions. Okay? And to my programmer brain, that looks good. That's the proper solution to something like this. You would take that one problem you had to solve and write a function that solves it. Because it lends itself to doing it with a function, because it will return different results for all different n. So if I call it with the n of 10, I get one result. If I call it for with 100, I get another result. It does the calculation for me, and then it returns the value to the calling function call. So here, SQOS, which is the second one, runs that, and I get back the result, and then I minus the result of that one, and I print the difference. Okay? So that is how we would attack Project Euler 6 if we were doing functions. Remember the magic of YouTube. Pause the video, boom, all that code is up there for you. Type it in, play around with it, make some changes. It's how we learn. Okay? Go look at the old video from the second unit where we did this with just loops. And then we were just solving things like a recipe going down the line. Now we're thinking more design-wise. Here's one solution. Here's another solution. And then let's go to a main program and use those problem-solving functions and get our answers. Okay? All right, so that's how we do things with functions. Oh, I'm not so bad. 11 o'clock. All right, 8 minutes. I got to go quick on this last one. Now, I'm going to warn you. Okay? If you are just barely hanging on, if you're thinking, okay, I think I got an okay handle on things, you certainly seem like you have things handled, and nobody's getting any bad grades. Everybody's asking good questions, so I think everything's fine. But if you're just holding on, then just go get a cup of hot cocoa and go to bed. Don't watch the next 10 minutes or the next 5 minutes, because I don't want to scare you. I don't want to do things that's spooky, but in the next 5 minutes, we're going to look at some bootleg Python, okay? Some scary stuff that us programmers aren't supposed to show everybody, all right? See all that work we did with loops, and all of that work that we did to find that solution? What if I told you that I got nothing in my hands and nothing up my sleeves, that I could do that entire problem in one line? One line of code. I could solve that entire problem. Okay? A little Python parlor trick. We're going to talk a little bit about something called list comprehensions. I'm going to save this code. Don't be frightened. Come with me. Said the spider to the fly. All right, do I want to, let me clear this out. Where's my Python? There it is, 37. All right, so now we got a blank canvas. All right, I don't know how many math papers you've read, but if I want to define a list of numbers, okay, I'm not going to say, give me a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And even in your programs, sometimes if you want to have a list of 100 numbers, well, what would you do? You would jump into a loop, and then like we did with our code in the Unit 2 quiz, you would append I 100 times, boom, boom, boom. It gets kind of old after a while. If you read a decent amount of math papers, which unfortunately I have, you will see that mathematicians have a certain way of describing number sequences. And they'll start off their things for x in, x does this, and x goes up the line and does this. For x in this particular group, what is the sum of x squared and blah, blah, blah. Well, Python kind of has a shorthand that allows you to do something like that. Let's say I wanted a list of the first 10 numbers, okay? I could do that. And then I type my list and I have that number, right? But I could also, if I wanted to save time, define the list for Python. Because what if I wanted my list to be 1 to 100? Then I would have to type out 1 to 100. It would be a pain. Do I want to take the time to set up a loop and populate things that way? I could. But Python lets me say x for x in range 1, 11. Same rules. First thing you don't want. And hit enter. And it gives me that list. Okay? And it even lets me assign it. All right, I'm trying to go quick, but I don't want to make sure I make any mistakes. So now all of a sudden I've captured that. Okay? So now I can define what I want my list to do, and Python creates it for me. It's called a list comprehension. That said, you can do some neat things with a list comprehension. I don't have to just list the numbers. Look at this. I can say x squared for x in range 111. And it gives me the squares. Okay? I could say x for x in range 1, 11 if x modulo 2 equals 0. What's that? That's the evens. Okay? Now, because I'm a little bit lazy and because I want to save time, I'll go with the saving time excuse. I'm going to copy that. I'm going to paste it. And this time I'm going to go back and I'm going to say not equal to 0. That's going to give me the odds. Okay? If you know how to describe your list, then you can tell Python what you want it to be, and boom, Python creates it. There's one last thing I'm going to show you, which is going to really come into play. I can use functions. X for x in range 1, 11 is, and I want to close that second paren. I want to close my list. And it gives me a one item list, but you know what? That one item is basically the answer to an equation or something I want. And now if I want, I can do this. Now the first 10 numbers, I'll just get that much. The first 10 numbers, not a big deal. You do that by hand. What if I want to do this for the first 100 numbers? Okay? Boom. You know what it's going to be? It's actually an old math story. It's 5,050. Because if you think about it, what's 0 and 100? It's 100. What's 1 and 99? What's 2 and 98? What's 3 and 97? Basically, what you have is 50 pairs of that add up to 100. Okay? But, and this should be good for you because you're now a computer programmer, we started with 0 because we said 0 to 100. So we have to account for 101, kind of like our range there, 101 items. That 50 is sitting there in the middle and it doesn't have anything to pair with. So you just add it. So the answer is 5,050. I think it better be. It better be after that stupid story, and it is. Okay, that's a famous math story. Professor wanted to give busy work to a class and said by hand, add up all the numbers from 1 to 100. And the student just raised his hand, and I think it might have been Hardy or something like that, some famous mathematician. And he says, yeah, it's 50-50. And that somehow they accused him of cheating. I remember, it was a long time ago. Maybe they accused him of being a witch. I don't know. That's certainly a better story. And then they ran him into the woods. Anyway, I can do a sum like that. So now I'm thinking to myself, sum of x squared for x in range 1, 11. I'm going to end that second one, and I'm going to end that. So now I can add all the squares from 1 to 10. Does that number look familiar? Now I can sum x for x in range 1, 11, but I want to take that number and I want to square it. No, actually, what do I want to do? I want to take the sum. That'll grab the whole thing? Yes. And I want to square that because I want to add everything up and then I want to square it. So I want the square of 55, whatever that is, 3,085 or whatever. Will it work? Oh, my goodness. So now I have the square of the sums, and I have the sum of the squares. Okay? So, if I were a clever boy, I will copy. I'm going to add a paren here so I can close it off. Paste that. Close it. I can take the difference of copy this and this. Does that sound out right? Yes. And the bracket. So I have now the difference between the square of the sums and the sum of the squares, and the range is 10. Do we think the answer is going to be 2640? 2640. Now, for my last trick, copy. We all know Project Euler wants us to do the first 100. So, in one line, using list comprehensions, we've solved Euler 6. Okay? Now, like I jokingly alluded to at the beginning of this is just, like I said, this is a parlor trick. I don't expect you to use list comprehensions in your code. I do not expect you to know how to do this for a quiz. Okay? This is just a nice little extra for you to play around with, maybe gain some facility with solving problems quickly at the interactive window. Okay? And you're Python programmers. You're part of the family now. You need to see this stuff because a lot of programmers know about list comprehensions and will use list comprehensions. Python is very popular. You know this. It's an MBS program. Python is very popular in the scientific community because it's easy to learn, the syntax is simple, and it allows scientists to act like scientists. they're used to doing back-of-the-envelope calculations and doing things really quickly. And Python allows you to almost use the interactive window as a quick calculator and a way to jot down your logic and get the answers really fast. And then you can also write programs and codify your logic and do things like that. But sort of like in, and I always harken back to the math sense, describing lists or describing worlds of numbers and thinking about things with a description and not just a solid list, well, that to me is kind of what a list comprehension is. And because you're allowed to use functions within that context, you can cheat and solve problems and then get little one-item lists that happen to contain your answer, okay, if you do things like we did. And again, magic of YouTube, pause the screen, take a look, and you can copy exactly what I did right there, and then you can play around. You can do odds to 100, you can do odds to 1,000, you can add up everything up to 1,000,000, you can do whatever number theory-ish wise you can figure out. You can figure out primes. You can do a lot of different things within list comprehensions. They're actually, it's kind of fun, and you could probably even come up with a programming contest where you just have to come up with clever list comprehensions. You can make decisions, as you saw up here with the if. You can use functions. You can do a lot of different things with list comprehensions. And as you saw, you were probably like, how in the world are we going to do that entire problem with just one line? But as you can see, in just one line of code, boom, we're able to do Euler 6. Once you gain some facility with Python, you know what it's about, you know what you can do, you're going to be able to do all that kind of stuff too. You're already getting there. You don't know it yet, but you're a couple weeks away from having the basics down. And then it's just a matter of practice. Practice, 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 and then all of this stuff will be second nature, and you'll have this in your brain. A year from now, if you go back and look at this video, if I still have it up, and I may, because this isn't one I will take down, you're going to notice in a couple of weeks, I'm going to take the Unit 2 homeworks video down, because I don't want people to see that before they do the homeworks. So whenever I do reviews of quizzes or reviews of assignments, boom, boom, I take it down. This, though, is something I may leave up. You come back to this a year from now and look at this, you're going to go, oh, look at how simple that was. I remember the first time I saw it, I thought it was complicated, but it's not. It's actually pretty simple. All right. Announcements are going to be quick because I'm going to be talking to you again tomorrow. Hopefully, now, I did this Wednesday night, so tomorrow night I can do the homework video, and then Friday night I can kill the Ender Dragon. Hopefully. I want to kill the Ender Dragon because Microsoft, who I am not a huge fan of, but Microsoft has been good for Minecraft because the way they set up realms back in the past, when it was just Mojang, then you had to do servers and there was all kinds of insanity going on. One thing Microsoft as a big brother is they're huge and corporate and they can do cool things on the cheap. And one of the things they did was realms. So for like $7 a month, I can set up a realm and I don't have to be there, but my nephews can go in and tool around. And if I'm there, that's great. If I'm not there, it's still up in the cloud running. So it's neat the way they did things. So we have a world, and slowly but surely we've been going through and doing this stuff. We've done the mining. We've done all that other stuff. If people don't play Minecraft, then just ignore my idiocy. So we made all the gardens. We raised all the animals. We went down. We found an abandoned mine, and we took all the wood, and we killed all the animals. Then we went to the nether, and we got the nether brick, and we did all the things we had to do down there. So now we're getting ready. We're trying to kill endermen so we can make ender pearls and we can find our way to the portal and then we can get to the end. Because pretty much the last big thing we have to do is kill the stupid dragon. Then once we kill the stupid dragon, then we can put the realms to the side for a little bit and go take a look at Minecraft Dungeons. Because the new game came out a couple weeks ago. It's not something you can use in realms. You have to have an individual setup on your machine. But once you're set up and running, you can invite other people to play in your game. So you can do a co-op in that particular game. I don't know how this turned into a Minecraft video all of a sudden. But that's basically what I'm going to be wasting my time with over the weekend. So I want to get you all these videos now so that you have ample time to do your assignments. When I drop this video, 11:15, oh, I did go long. Sugar. Oh, God, I went 20 minutes. I went 20, 25 minutes. All right, I got to stop. Tomorrow I'm going to get you that homework video, and then I'm going to give you time to work on the problems. I'm going to drop the first assignment tonight, and then I'll probably drop the big boy tomorrow night at the same time that I do the video. And then you'll really have all your resources, and you'll have an entire 8 days to work on everything. Okay? I promise. I know you're getting a lot, right? Like rapid fire every day, a half-hour video to watch, plus assignments, plus you got to do your discussion post and blah, blah, blah. But, welcome to grad school, right? All right. I'm going to get out of here. You be good. Don't let list comprehensions mess your brain up. You worry about Unit 3. You worry about the stuff in Unit 3. You worry about functions. You worry about file I.O. You worry about libraries. You worry about import. Yeah? You worry about that stuff. Okay? Worry about scope. Worry about return values, arguments, file names, things like that. Don't worry about list comprehensions. It's just something neat. And that way, when you're at the water cooler chatting with the other Python programmers, somebody brings up list comprehensions, you're going to know what they're talking about. All right? All right. I'm getting out of here. You have a great night. I'm going to see you again tomorrow. If you're not sick as you're going to be. All right? Have a good night, and I'll talk to you later. Bye.